Alright, we're here with a problem from the differentiation section, 1996, question C, part 2. So, let's read PQ. The line PQ is a chord of the loop of the curve y squared is equal to x squared times 6 minus x, so that the chord is parallel to the y-axis. Calculate the maximum value of PQ. Well, you can see here they've drawn out a chord, and they're actually giving you quite a bit of a hint when they're drawing out that chord, because if you look at the curve, they've drawn out this chord at actually the biggest point, and just like any other line, the maximum point is when the slope is equal to 0. So you just draw any other slope 0, so it's just when it's a flat line across the top. That's your maximum point. So we can go through, and when the slope is the derivative, so we set the derivative equal to 0. So I'll get started. So that will find us the top point here, and bottom point down here. The x values should be the same, and the y is just the minus of the other. So let's get started. So y squared is equal to x squared multiplied by 6 minus x y. So let's find the derivative. This is an implicit differentiation because we have a y as sort of a function. So we have to get the derivative of this whole thing. So use the chain rule. So you have 2y times the derivative of the inside, which is dy dx, is equal to, this is a multiply, so it's product rule, so it's x squared times the derivative of this inside, which is minus 1, plus 6 minus x times the derivative of x squared, which is 2x, and we'll divide it. We'll keep this over here, so we have 2y dy dx, simplify the other side, so it's a negative x squared plus 12x, 6 times 2, minus x minus 2x squared. Divide by 2y to get the derivative on its own. 2y dx is equal to negative 3x squared, and that's it. That's a 12 plus 12x over 2y. Now, if we're going to find when the slope is equal to 0, we'll just set this whole equation equal to 0, and this whole equation is then equal to 0 when the top bit is equal to 0. So we've simplified it quite a bit. So we'll start again. So we'll go, just take the top, we'll go 3x squared plus 12x is equal to 0. And we can factor out 3x from there, so we can go 3x times minus 1 plus 4 minus 3x times minus x plus 4 is equal to 0. So in this case, when two things multiply by each other and they're equal to 0, if either one of them is either part can be 0, so it can be this half can be 0 or this one is 0, and then the whole thing will be equal to 0. So we can have 3x is equal to 0, and that means x is equal to 0, or we can have negative x plus 4 is equal to 0, and that of course gives x is equal to 4. So now we found the x coordinate of this thing. We know that this point here is 4, 0. Now we can find the y by substituting back into the original. So we get y squared is equal to 4 squared times 6 minus 4 is 2. So y is equal to square root of 4 squared, which is 16 times 2, which is y is equal to square root 32. Square root 32 is like saying 4 times y. 32 is like saying 4 times 8, and then that is just like saying square root 4 times square root 8. We know square root 4 is 2, so that's just like saying 2 square root 8. And that's our y. So that's this point up here. We know that we know this point up here is 4 and 2 square root 8. So we know the height of this, and then just it wants us to find the maximum value of p, which we figured out to be the highest point in the whole curve. We found the point here, so the p is from here is this, and it's perfectly symmetrical. So you can just do multiply the y value by 2. So we get p pq is equal to 4 square root 8. Okay, thanks.